Hello, good afternoon, sir.
Good afternoon. So you are Shivendu Tyagi, am I correct?
Yes, sir.
Okay. Hi Shivendu, this is Rahul from Pepcoding, and I can see that you have applied for data scientist role in our company. Am I correct?
Exactly, sir.
Okay. So Shivendu, let's start this interview with a brief you can say introduction about yourself. Please introduce yourself.
Okay. Hi, my name is Shivendu Tyagi. I am a student currently pursuing my graduate from Guru Gobind Singh Indraprasth University, specialized in electrical and electronics engineering. I have scored an overall CGPA of 8.8. I have a good knowledge of Python, machine learning, and deep learning. Along with it, I also love going for bike rides, listening to some music, playing cricket, and yeah, that's it about me.
Okay. So like you were already you were like you liked coding or you learned it after, because I can see that you are currently in electrical. So when did you start learning all these machine learning and deep learning concepts?
Exactly. So basically, I had C++ in my 11th and 12th, and due to some unfortunate things, I had to opt for electrical engineering in my, engineering. Otherwise, I was willing to go for computer science engineering. But still, I had interest, so I kept on exploring these fields in, computer science, and I finally got into data science, and I continued exploring over there. So that's why I know machine learning, deep learning, and all these things.
Okay, okay. So it was nice knowing you, Shivendu. So let's start with the interview, shall we?
Exactly,
Okay.
sir. Let's.
Okay. So you are familiar with machine learning and deep learning. I assume you are more familiar with deep learning. Am I correct?
Yes, sir. Yes, sir.
Okay. So in deep learning, you can say that we have neural networks. I hope you are familiar with them.
Exactly, sir.
Okay. So, but can you please give a brief type of neural networks that we have in machine learning and deep learning?
So basically, we have three types of neural networks. Basically, we have artificial neural network, we have RNN, that is recurrent neural network. Then we have the major CNN, that is the convolutional neural network.
Okay. So, are you familiar with CNN?
Exactly, sir. Yes, I'm familiar with it.
Okay, so let's start with CNN. Okay, so my first question is, in layman terms, just please explain to me what CNN is.
Okay. So can I write it over whiteboard?
Please, 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 by all means.
Okay. So firstly, let's start with its full form, that is a convolutional neural network, right? So what I mean with CNN is it is used to visualize the things, right? This particular network helps us to visualize things, right? And by visualizing, what I mean precisely, I mean that it is a neural network. It is a neural network that can perform analysis on images and visuals, right? So this is what I mean by CNN, and these this particular CNN neural network, it is widely used in image recognition, image classification, object detection, and these kind of things. So precisely what this is what I mean with CNN, that is
Okay,
convolutional neural network.
so is CNN only compatible with images? Like we can only apply CNN with images, on
Exactly.
images?
Yes, sir.
No, I don't think, because we can apply images with text, images, audio, etc. There is no such like fact that we have to apply only with CNN, only with CNN. Okay, you can apply it with text and other things as well. So okay, let's move over. Okay, so you say that CNN is convolution neural networks. Okay, and CNN is majorly used with images. Okay, so please tell me that what does CNN do with an image? Okay, I want to know the inner working of that CNN.
Okay, so basically, CNN has different layers, and these different layers do what? These different layers extract the features, okay, right? They extract the features of the images, and they use these features to do perform classification of on our testing, right? And this extraction is done through the various operations which we have in CNN. That is, we have pooling, we have striding, and we have padding, and these particular things perform operations on our images. They do feature extraction, and then we have left with the classification work, which is also done in our CNN. So that is it.
Okay, okay. So you say that CNN has different layers. Can you please tell me about these different layers?
Okay, so firstly, the most common layer we have is our input layer in our CNN. right? This input layer is a bit different. What it does is it we have a image that has three dimensionals, right? And it converts, it reshapes this three-dimensional image into a single column or into a single row. Why it does that? It does this particular operation to decrease the computational time of our neural network, right? If we have this particular matrix, it will be very tough to compute, and then on the other hand, we have a single row that will be very easy to compute, right? So this is what is the role of input layer in our convolutional neural network. And then we have the convolutional layer itself, right? Basically, what I mean by this particular thing, that is convolutional layer, what I mean by this is this layer is used to create several smaller picture windows to get over the data, right? It tries to perform some filtering over our big image through a small filter, or I can precisely say that we define the filter size of the filter which will get over our data. And this is our third convolutional layer. Then we have also the activation functions which we use in our CNN, and we generally use ReLU. And if I come on layer, then we have our pooling layer, right? We have the pooling layer, and pooling layer is a downsampling operation that reduces the dimensionality of our feature map. And this particular feature map we generated through our ReLU activation function, or I would say activation layer. And after that, we have fully connected layers, and then we have we can also have a softmax layer, and then at last we are left with our output layer, which contain the label in the form of one hot encoder or any.
Okay. So let's say you said that this one picks out the features. Am I correct?
Sorry.
Convolution there helps to pick out the features. It helps to filter the features.
Yes, sir.
And pooling there also does the same.
Pooling layer, yes, sir. Pooling layer basically does what? It performs the downsampling, right? Whatever features we get over this convolutional layer, the pooling layer does the downsampling of that particular feature map. This is what I told you. Pooling layer.
So does pooling layer always perform downsampling?
So basically we have to specify, right? We have to specify the things, and accordingly our pooling layer will perform, right? What I mean by specifying things is we have max pooling, right? We have max pooling, we have a very different of types of pooling, and accordingly it will perform the things.
Okay, but okay. So there are two things in CNN. There is downsampling and there is upsampling.
Yes, sir.
Okay. So downsampling, you can say, is performed by this. You can say this pooling layer. Am I correct?
Exactly, sir.
So which layer performs upsampling?
Sir, the upsampling is, I guess, performed through our, I guess, our ReLU layer can perform the upsampling, I guess.
I think ReLU is not a layer; it's an activation function.
Yes, sir, it is an activation function, but when we apply the activation function, it gives a rectified, a rectified feature map. So through this, the output of our ReLU is a rectified feature map. So through this, I can guess that our ReLU.
Okay. Now you have told about pooling layer. Okay.
Yes.
So please specify what are the types of pooling layers that we generally use in CNN.
Okay, sir. Definitely. So basically, we will start with types of pooling layers. To be precise, I would say types of pooling layers, right? So firstly, we have max pooling, right? We have max pooling, and it is
just
basically.
give me the names. I don't want that. I don't want to know the details. Just provide me with the names.
Okay.
What are these?
Okay. I got it. So we have max pooling, we have average pooling, and then we have global pooling. And yeah, I guess these three pooling layers are majorly used. And
okay. So very good. Now let's say, okay, just let me remove it. this thing. Okay. Okay. Let's say I have this window. I have this image right here. Okay. So you need to tell me that how will convolution layer act upon this feature? Like what all things it will use to gather out to extract features out of this image. Are you? Did you understand the question?
So can you please repeat so that I can get it in a more
Okay.
better
Okay.
way?
Let's see. You told me that CNN works on images only. Am I correct?
Yes, sir.
Okay. So this, let's say you have this image. Okay. This is an image. Obviously, you need to feed it into an input layer.
Exactly, sir.
Then it will perform some features. It will pick out some features. Feature extraction will be done on this layer,
Yes, sir.
on this image, sorry.
Yes, sir.
So how does that feature extraction work? Like we have some things that perform these functions for us. Can you please specify them?
Okay, so okay, I can tell you this in detail. Firstly, let's start with the basic thing of taking out the features. We have a feature matrix, or we can say we have to specify the feature size, right? There is a matrix which will act on our input image pixels, right? It will act on the input image pixels, and this particular thing is a feature size which will act on our input image pixels, and it will take out those pixels, and accordingly we have to give the size, right? Suppose I give the feature size of 3 cross 3, right? So basically what it will do, it will make a pixel, it will make a box like this, and in this particular image, in this particular section, it will take out all the features which are stored in this particular matrix on our main image, right? So this is how the feature extraction is done, right? And suppose there are a lot of pixels over here. So what we do nextly, we need to specify the striding, right? There is a term striding, which is also an operation performed on our in our CNN to do the feature extraction. What striding does, striding refers to the pixels, refers to the number of pixels by which we slide over the filter matrix, right? We slide the filter matrix over the input image, right? I'm sorry, we slide the feature matrix. I told you that there is a feature matrix, and we need to move it, right? We need to move it over here, and so that it can capture all the features of our image, right? So this striding specifies that how much you need to slide on our input image, right? I hope you got about striding. And then we have a thing called padding. And padding is basically an optional thing. What it does, it adds some extra pixels over here, so that so that it becomes universal. So that how what I mean by universal, that it should not lose some features which are here in the last, I would say, last column, so that it gives the extra pixels to our feature matrix, so that if we have left only with one column, so that it will give extra pixels, and the feature will take this particular padding pixels, and it will capture that particular column also, so that no particular column of pixels will be left and no particular information will be lost. That is the main function of padding over here, right? And after applying all these operations, we at last get with the convoluted matrix, and we get the dimensions of the convoluted matrix through this particular thing. I hope I'm clear with it.
Okay, that was an in-depth knowledge. Okay. So okay. So let's see. Okay, now so let's see that let's say my input image. Okay, I have an input image that has been converted into 36 cross 36 matrix. Okay.
Okay, sir.
Okay. So and now I have a filter size. I am applying a filter size of 4 cross 4.
Okay, sir.
My kernel size is 4 cross 4 and my striding is 1. Okay. So please tell me what would be the dimension of my convolution layer.
Okay, sir, definitely. So for this particular computation, for this particular mathematics, we have the formula. We have the precise formula that specifies the size of our convoluted matrix, which will get performing these particular operations which you have specified, right? So I will start with the specifying the formula over here. Okay, where is right? So what is the formula is n minus f plus 2p, and we divide it it with S and we add 1 over here, this particular thing gives the dimension, right? And we have only one dimension over here. So for the second dimension, the value which we will get over here will simply come over here. Suppose we get 10 in it, so the convoluted matrix dimension will become 10 cross 10, right? So accordingly, we will try to apply this particular formula in the information which you have specified, right? So firstly, n over here will be the size of the input matrix. You have specified that we have 36 cross 36 input matrix. So we will put 36 over here, right? And we will put 36 over here, and F here stands for the filter matrix, right? And you have specified filter to be 4. And I'm assuming this striding value is 1, I guess, right? Am I right? So the striding value is 1, and you haven't specified the padding value, so I will assume it to be 0. Okay.
So keep the padding to 0. Keep padding to 0.
Yes, sir, correctly. That's what I was telling. And okay, so we have 36 minus 4, and padding will be 0. We will divide it by striding. That is 1. So obviously we will get 32 over here, and I will write it over here. 36 minus 4, that is 32, and plus 1, that is 33. So we will get answer over here that the size of the convoluted matrix will be 33 cross 33.
Okay. Good. Okay. Now, okay, that's enough about CNN. Let's talk about architectures of CNN. Okay, so are you familiar with architecture of CNN?
Yes, sir. Exactly.
Okay, so please tell me what do I mean by architecture of CNN?
Okay, sir. I will tell you in a second. So architectures, what I mean by architectures. So basically, what I mean by architecture is that we have a convolutional neural network, right? We have a convolutional neural networks, and there were different, methodologies which were similar of traditional supervised learning methods, right? That they receive some input, they detect the features of them, and then they drag a grader on it, they drag a filter size on it, and through that particular filter size, we have something in our output, right? So that was what done in our architectures, right? We provided some traditional neural networks, and it will do what? It will do all the computations, and we just need to apply our architectures on our images, and it will definitely do all the desired computations which are predefined, and all the weights and all the biases are obviously predefined in our architectures which we have till now.
Okay, so but what does the architecture mean?
So
what do I mean when I specify architecture?
Yes, sir.
Okay, something, but what does architecture mean? Like if I am specifying that this right here is architecture 1, this right here is architecture 2. So what would be the difference between these two?
Okay, sir. I will say. Okay, so it is definitely a CNN, right? It is definitely a convolutional neural network, right? And this particular convolutional neural network. So basically, what I mean by architecture over here is, again, I will say that we have in architectures we have the fixed operations which I have told you till now, that we have a fixed filter size, we have a fixed writing amount, we have a fixed padding, and these particular things are fixed and they are put inside a box, and that particular thing is called the architecture, right? And if we will change those things, we will change those specified things, then the architecture will have no use over that particular situation.
Okay.
This is what I mean.
Okay. So, which architecture do you know the most about? You can say that I know the most about this architecture?
Sir, I would say that I know the most about the architecture, that is ResNet architecture, ResNet 50 to be precise.
So ResNet 50 or ResNet 100?
ResNet 50, sir. ResNet 50.
Okay, ResNet 50.
Yes.
Okay, so why is it called ResNet 50?
So ResNet 50 is basically ResNet specifies here the residual network, right? And the 50 stands for the 50 layers which it has, right? It has 48 convolutional layers, a max pooling layer, and that's how it is called as, and average pooling layer, and that's how it is called as the ResNet 50.
Okay, so let's start with ResNet 50. So please tell me in depth about ResNet 50. How does ResNet 50 works and everything about that?
Okay, sir. Okay. Can I erase it, sir?
Oh, I'll do it. Okay,
Yes, sir. Thank you so much.
continue.
Okay. So
Okay,
basically, okay. Now let's come to the ResNet 50, right? ResNet 50. ResNet 50, it is a basically a neural network, definitely a convolutional neural network or an architecture, and it is widely used ResNet model, and we have just got to know about this particular thing, that it has some 48 convolutional layers, a max pooling layer, right? So now let's come to its functionalities, that what it does different from other architectures and why it was introduced. So the major thing of our ResNet 50 is it solves the problem of vanishing gradient, right? The vanishing gradient problem is solved in our ResNet 50. And how it solves the problem, let me tell you. What it does is, suppose we have an input X, and we have the ResNet 50 layers over here. Suppose some the weight layers we have over here, and then we apply our activation function, and to be precise, we will apply ReLU, and then we have some other layer over here, and then we get our output here, right? I have reached my output, that is fx. Can I call it fx? Yeah. Okay. So what ResNet 50 does unique is it adds our input x directly to our output, right? It adds the input x directly to our output, and this particular thing that we are adding the input directly to the output is unique in our ResNet 50, and it solves the problem of vanishing gradient very easily, right? Very easily. So instead of getting fx as output, we will get the output as fx plus x, right? So and yeah, this is the most basic and most simple functionality of our ResNet 50. That's it, sir.
Okay. So how does adding X solves the problem of vanishing gradient here?
Okay, sir. Adding x over here. Um, Yes, sir. Adding x in over here, it solves the problem of vanishing gradient in a way that suppose we had the layers over here, and we had the layers over here. The vanishing gradient problem is basically that the gradient becomes so less that it stops. It stops getting changed, and the model cannot get better and better, and the errors are not the errors are not changed accordingly, and we do not get the desired output. Even our neural network stops working, right? So if we will add x directly over here, so that it will change the gradient in our output, and it will definitely make our fx. We try to make one thing I forgot about it. We try to make our fx in the ResNet 50 0 over here, so that we will have a fresh value x, and this x will solve the problem of vanishing gradient, and it will adapt uh, in it directly. And yeah, this is you know this is how it solves the problem of vanishing gradient when we add x directly over here.
So this Fx right here, is this your output?
Yes, sir.
Okay. So okay, let's assume that I am building at a classification model. Okay.
Yes, sir.
Okay. I am using ResNet for classification. Okay. This X, it is obvious. Let's say this is my input layer. Okay. So is there a chance that this x would be greater than greater than 1? Is there a chance that it x would be greater than 1?
For classification, no, sir.
Okay, so let's assume that its value is between 0 and 1. Am I correct?
Yes, sir.
Okay, and then you process everything, and then you say that you try to make this fx as close to as 0. Okay.
Yes, sir.
So now what you do is you add this x directly here.
Yes, sir.
Correct? So how can you say that your model is accurate? Because all you're doing is you are making this fx 0, you are making the output 0, and then
Yes, sir. Yes, sir. Yes, sir. I guess your voice was cracking, sir. Hello.
okay, so my voice is audible, Shivendu?
Yes, sir. It's audible now.
Okay. So you said that we try to make this fx close to 0, correct?
Yes, sir.
Okay. And now what I am doing here is, you said that we add this x, we add your x to fx. Okay. So now this x is something random that our model will receive.
Yes, sir. Yes, sir.
Okay. So what actually you are doing is, you are passing this random value as an output, and you are saying, is your model, will your model be accurate by this?
No, sir. No, sir. Definitely not.
Okay. So there is something that you are saying wrong. Okay.
Exactly, sir. Exactly. Exactly.
Okay. I
So
hope you would. So okay. Please continue.
okay. So I was just saying that yeah, that fx doesn't need to be zero over here. Definitely, it will hold some value. That
Okay.
was what I was trying to correct myself.
Okay. 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 Very good. Vinay. Okay. So Shivendu, have you built any projects in deep learning?
Yes, sir. Definitely, I have built the projects.
Okay. So please tell me about something about your projects that you have built.
So basically,
Something which includes CNN. Something which
definitely.
includes CNN.
Definitely, sir. Sir, I made a project on the flower classification. I had a data set which had some, different kind of flowers. Basically, there were 5 types of flowers, and we had images. So we had to classify the images, and I used a ResNet architecture, this particular architecture over there in my model, and yeah, it did.
So why did you use ResNet? Why not any other architecture?
So basically, I was working considerably on the ResNet 50, and as soon as I got to know that yeah, there is no such headache of vanishing gradient, so I just thought, let's try ResNet 50. Why not? Let's try ResNet 50, and yeah, it took little bit time in getting trained, but yeah, it made quite
So
impressive results.
okay. So what was the accuracy of your model?
So accuracy was around, I guess, if I'm not wrong, it was around 73%, I guess. I'm not
Okay.
sure. I'm not sure, but it was around 70.
Oh, that's fine. That's fine. It's a good accuracy. Okay. Any other projects that you have built, Shivendu?
Yes, sir, definitely. I've built projects. I have made projects on GAN, the generative adversarial networks, and I have made even more projects in our CNN, and I'm forgetting one of the project. It had some, it was related to some person classification. We had a data set over there again, and we were given some labels, so we had to classify there over again. So that these are some of the projects which I've made worked more on GAN too. So that is under one of the
Oh, okay. Nice, Shivendu. Nice. Okay. So that's it for this interview, Shivendu. It was very nice talking to you. Do you have any questions regarding this interview?
um, okay. So not right now, not right now.
Okay, okay. So, okay, so it was nice talking to you, Shivendu. Just okay. So if you are selected for further rounds, then you will receive a call from our HR. Okay. So I suggest you sit tight and keep your finger crossed. Okay.
Yes.
And it was very nice. It was nice talking to you. Okay. So okay. So Shivendu, you can leave the meeting now. Thank you. It was nice talking to you.
Thank you so much, sir. Thank you so much.